So now on to part B, where we're asked to find the value of x that minimizes the length of fencing required. So when we hear this thing kind of minimizing, maximizing, what we're going to be looking at is differentiation. So we're going to be minimizing this expression here. So when do the minimum points of a function occur? Well, they actually occur when the stationary points occur, and where the stationary points occur, they occur when the derivative of a function is equal to 0. That means it stops changing, so it's stopped getting smaller, so it's the smallest it can be, therefore it's at its minimum. Okay, so Lx equal to 9x plus 144 over x. So what we're going to do, we are going to find the stationary points. So the stationary points occur at L dash x equals 0. Okay, so L dash, well, Lx first, Lx equals 9x plus 144 x to the negative 1. Okay, so now we're working at L dash x equals, this just becomes 9 minus 144 over x to the minus 2. So this becomes 9 minus 144 over x squared. Okay, and now we're going to set this equal to 0. So this then becomes 9 equals 144 over x squared. So x squared is equal to 144 over 9. Then x is equal to the square root of 144 over 9. So make it clear it's the square root of the whole thing. Okay, and you know, this could be plus or minus because we don't know which one it's coming from, but actually we do because we're talking about length here. It's always going to be a positive because you can't have a negative length because of length must be positive. Okay, so we can just type this into our calculator. So x equals so the square root of 144 over 9 equals 4. So x equals 4. So the mistake not to make here is when is to end here. Now we need to prove that this is actually the minimum. This is actually minimum point. So what we'd have to do here is do a nature table. So we've got x, and we have you know, people like to do these different ways, but I like to do it like this: 4 minus, 4 plus, L dash x, and then you have slope. Okay. So what we're going to do here is put a number smaller than 4 back into the derivative and see what we get. Okay, so in this expression here, we're going to be, so if we do 9 minus 144 to the power all over 3 squared, we're going to get a negative number. So we get negative, and then if we do a number bigger than 4, so 5, we get a positive number. Okay, so that means it comes in like this, goes in like that, and then it goes. So that's confirmed that it's a minimum point. So we have min turn point at x equals 4. So that usually is enough, but if you want to write a statement, which is to make sure you're going to get all the marks, so you have something like this: value that gives minimum amount of posts or minimum length, min length, the value of the value that gives minimum length is when x is 4 meters. They haven't actually asked you to figure out what the minimum length is. What you'd have to do is put 4 back into this equation, and that would give you your minimum length. So I think let's go back and see where you get the marks from. Well, you get 1 mark to know and to start differentiating. So here you get, well, not there, I guess. Yeah, you get 1 mark for here for knowing to differentiate. You get another mark for completing the differentiation. You get 1 for setting equal to 0. You get another mark for finding the x value. You also get a point for verifying the nature table, and then you get your last mark for interpreting the result, basically saying there's a minimum at x equals 4, and this gives you the minimum length, so that's your last mark there, so it's 6 out of 6.